Databases, the backbone of many websites as well as enterprise level software. Well, a database is something that we have heard of, right, but maybe don't really know what's happening. So what we're going to do today is we're going to actually delve in, right? We're going to learn about what a database even is, and we're going to try our hand at some commands that, well, are commonly used to operate a database. Hopefully by the end of this episode, you will know exactly what a database is, as well as where it is powerful, right? What are the good things it can do, and where, it's not quite as good, right? How you should basically not use it. So yeah, all this and more on this Random Wednesday episode. Hello and welcome back to another Random Wednesday episode. So this video is quite long, so let's have a quick little contents page of what we're going to be covering today. First, we'll be talking a little bit about the basics of databases, right? What they even are, what they're good for, what they're not so good for. We will look briefly at what software is available. We'll talk a bit more about the specifics of how to actually build a database and what to expect in one, before we jump into our demonstrations, which will take up the bulk of this episode. Now, these demonstrations are meant to show you what SQL commands are available. These are by no means exhaustive, but what I'll try to do is I'll try to apply SQL in more practical contexts, so you can see how it could be useful in the real world. We will start with our very basic commands, right? Just reading back things, changing things, and then, well, we'll move on to more complex filtering and math operations. That will basically take us through for about the next 20 or so minutes before we wrap up our episode. So yeah, pretty long episode, quite a lot of things we're going to be covering. If you want to jump ahead, do pop open the video description. You will find timestamps to, well, each one of these parts. So alright, without further ado, let us begin with our episode. Now, here's the deal. I think most of us have the impression that a database is a storage tool. In fact, as it turns out, storage is not the main thing a database can do. Even though, well, technically, of course, without a storage, a database is kind of pointless. But in fact, the actual strong suit of a database is in the fact that it does search. You see, a database is basically, well, a piece of software that, well, does store some information, but its strong suit is arranging the information in such a manner on disk such that when you actually make a query, it's able to very quickly filter out, mix some of the data together and give it back to you. That is the key point of having a database. There are actually many different kinds of database software available. I think you've probably heard of MySQL. PostgreSQL is another pretty famous one. There are also commercial variants, some created by Microsoft, some created by companies like Oracle. So yeah, what this means is if you want to do databases, you'll find that there are many platforms available. Luckily, they all have one thing in common, and that is they all make use of SQL, the structured query language, which is a way for you to actually interact with a database. Now, this is, kind of like a programming language, but it's actually a declarative programming language. And what that means is you just express what you want, and how it does it really isn't something that you care about, right? It doesn't do things in a particular order, it just, well, does things and gives you back what you're looking for. With SQL, you can actually create very complex queries. You can actually, do a query, get a table out of that, feed that table into a subsequent query and do other crazy things. But again, we're not going to go there. Today, we're just going to look at the basics and basically try and understand why a database is just so powerful. Now, in terms of the actual software we're going to be using today, well, we're going to be using a much simpler version called SQLite. You see, most popular SQL databases run on a client-server architecture. That is, you have to install the software on a server and then have, say, maybe a web page or something like that access that server. I mean, of course, you can install it on your computer, but what I find is that because it is still server software, so it may create some services that run in the background, and you don't want that. So instead, we're going to go with SQLite, because SQLite is essentially just a way of creating a file, but what's cool is the way you access it is by using SQL. It is to a certain extent still quite efficient, but yeah, for the most part, we're just picking it for its simplicity. Also, there is a pretty cool tool that we are going to download and use, and that is this program known as the SQLite Browser. Basically, this program allows you to, well, read and modify an SQLite file without a need for, further programming on your part. Everything is graphical, you can actually see where everything is, you can actually even change up some information, create new tables, whatever. But today we're going to be, working with actual SQL, which the browser also allows you to do by going to the Execute Statement tab. So, very powerful piece of program, right? Go ahead and download it. You'll find a link in the video description. So, while that program is downloading, allow me to basically explain the basics of an SQL database. Essentially, a database contains one or more tables. Every table has some columns in it, obviously, and each column is actually assigned to a particular type. This is quite similar to data types in programming. And of course, you name each column, so you know what each column actually represents. Usually, in each table, we will have what is known as a primary key. The purpose of a primary key is to basically uniquely identify every row. We can use something, say, like an ID, right, which is just a number that, keeps going up. We can also create what is known as a composite primary key, in which we take, information from several columns and combine them together to represent a primary key. We can then populate information into each table. And what's cool is that we can later query this information, out from the table. So yeah, that's basically the idea in a nutshell. There are more complex things we can do, which we will cover as we move along. But for now, let's take a look at some simple SQL statements you can use to create, modify, and read. Alright, let's begin by taking a look at just some simple SQL statements. Now, if you want to follow along, you might want to actually pop open a video description. I'll have two SQLite databases already populated with some information. So the one I'm looking at right now is the one that has the countries in it. So yeah, you should see a list of countries, their populations, as well as their time zones. So just a simple example of some data in a very typical kind of format. This database is extremely simple. There is only one table in it. And yeah, those are the three values it holds, right? About 30 pieces of data. Let's now go over to the Execute SQL tab, and we're going to take a look at some just very simple commands we can use to interact with the database. We're going to start with the select statement, which, well, is just used to retrieve information from the database. At its simplest, the statement looks something like this: select star from countries. Now, the reason why I say countries here is because, well, that is the name of the table. When I run this, well, I basically just get everything back. This is just an exact copy of the contents of the table. While this doesn't seem very useful, as it turns out there is a lot we can actually do to this statement. Let's start with our star. Now, this actually means all columns. So in fact, when you say select, your next parameter is the columns. Now, our countries table has 3 columns: country, population, and time zone. So let's say now I didn't want to know anything about the time zone. I just want to know the country and the population. So I can specify the columns here, and when I run the statement again, well, we don't get the time zone column back. Let's try something else. We can also do some filtering. To do that, we need to use the where statement. So we say where, let's say population is greater than a billion. 1, 2, 3, 1, 2, 3, 1, 2, 3. There you go. So yeah, in this particular case, we only have 2 countries in our database that has a population greater than 1 billion. So as you can see, SQL can be quite powerful because we can use filtering to influence the results. Also notice that, well, my statement has actually gone over 2 lines. It doesn't actually matter. You can go ahead and, just spread out everything into as many lines as you need. This is especially useful to keep your code neat. For example, if I need to, check another parameter, well, I can do that. This one looks like your typical programming language. I say where population is greater than 1 billion and time zone is greater than 7. Let's say that. So in this case, we have now filtered India out of the results. We only have China. So that's the idea. Of course, filtering by numbers is not the only thing you can do. For example, I can say where country is like, so that is a keyword of SQL, and I can say percentage United. And what this will give me back are the countries with the word United in their name. Again, extremely powerful. We can also do sorting. So let's say, well, we don't use a where statement anymore. You simply say order by population. Of course, when you do this, you realize that the smallest population comes out at the top. And if we want it the other way around, no problem. Just say descending. And there you go. So the select statement in and of itself is something that we can spend a lot of time looking at. We haven't even gone to the part where, we actually use functions in conjunction with this. For example, I can still say select count asterisk, and this will give me a count of how many rows there are. So yeah, in fact, the select statement is one of the, well, I would say busiest, most complicated statements in SQL because there's just so much you can do. Of course, for now, we're only going to be looking at just the more basic operations. Yes, those were the more basic operations. As we move on, we'll take a look at even more complex select statements. For now, let's see what else is available. Probably the next best place to go is to add new items to the database. And we can do that using the insert command. So I will say insert into, specify which table, and then basically specify what columns I actually want to fill in. So you don't even have to fill in all the columns. In this case, I'm going to go ahead and fill everything in the right order, which you can also change up. So I want to start with the country, then the population, then the time zone. And let's go ahead and add the following values in. Of course, we have to specify it in the order we've just given. So let's say Singapore, population being this number, and well, the time zone is +8. So when I go ahead and run this, I can now go back and run our previous statement, right? Remember, we have previously looked at, a count statement. As you can see, the count has increased to 31. I can go over to the Browse Data tab and just quickly look for my latest item. There you go, there it is. So yeah, insertion. We can also do a deletion, right? So the syntax is fairly intuitive here. Delete from which table, and we say where. So this one is very similar to your select statement from just now, right? Basically, you give it something to search for, and you say you basically want to delete whatever matches. If we go ahead and do that, now when we actually view the data, you will find that, well, we are left with 30 items. Singapore has been deleted off the list. Now, this is actually where some pretty scary things can happen, because all we're trying to do is we're trying to match this condition. So whenever this is true, the corresponding item will be deleted. What that means is if we put in something like this, where 1 equals to 1, well, that's always true, right? So when we run this, now we've actually wiped out our entire database. So yeah, that could be pretty dangerous. Luckily for us, this database browser actually allows us to revert changes. So, well, I can go ahead and revert my changes and everything will come right back. Of course, if you make a change that you do indeed want to save, you'll want to use the Write Changes button. Otherwise, the changes will not be reflected on the database itself. Let's look at some more commands. We can also use an update command. And of course, what this does is, well, it changes a value. For example, I can say, just as a simple contrived example, set time zone to, let's say, 100, where country equals to, say, India. So now, if we were to actually go back, we will see that we have indeed updated our time zone. Of course, I'm going to go ahead and revert this change. And again, the same risks actually apply, when it comes to writing a statement that could possibly affect everything. For the case of update, it's even easier to make this mistake, because if you were to just omit the where statement and you run it, well, everyone has their time zone set to 100 right now. So again, we're going to revert this change. So yeah, when it comes to certain types of SQL statements, you do have to be very careful. So far, the statements we have seen are those that, you would call on a day-to-day basis, right? As long as you're working with the database, these may be things you need to use. However, some other statements may exist on more of a setup basis. Now, in this particular case, we have, already set up the table by default, right? But what you can do is you can also go ahead and run your own create table statement. So let's quickly try that. Basically, what you're specifying when you say create table is, well, the name of the table, the columns, and their type. So let's say we have a column 1 that is a number, and a column 2 that holds text. When I run this, and if I return to just our main menu, you will see that, well, our test table is here. Later on, what I can do is I can run some more insert statements to populate this table with data. So yeah, what that means is you don't really need this GUI to, build your tables. Everything can be done in SQL itself. In this particular case, we use the GUI to make things a little bit simpler for us. Now, there are many other commands we haven't actually seen. For example, some are used for more administrative purposes, where if you have a proper SQL server setup, you can actually go in and create users, change their passwords. But let's keep things simple and just, try to understand the general idea of how SQL works. Of course, we are nowhere near the end yet because we have yet to see the most amazing part of SQL. So alright, now that you've seen the basic statements, let's now actually try and do something a little bit more advanced. Now, did you know that the select statement can actually, take information from multiple tables? Yeah, that's right. Just give it 2 tables and see what happens. To demonstrate the second part of our video today, I will be using, our other database example, which is the file called sales. In this one, we actually already have 2 tables set up for you. Technically, there is a third table, but let's go ahead and ignore that. So this is supposed to be, just a very simplified example of some kind of sales system. Our first table will hold the prices of our products, which we only have 4 of. And our second table is going to hold some information about our actual sales. What this tells us is what product has been bought and at what quantity. We also have an ID, just to enforce a primary key. This ID has actually been set up to, be automatically incrementing. So yeah, that's a pretty cool thing because we can actually just set that up, and every time we add a new record, this is actually populated for us. SQLite will know what number to put here, right? And it will automatically increase with every new item you've added. Of course, we're not going to go there because, for now, what we're trying to do is to learn about more in-depth query methods. And in fact, from this point onwards, we are only going to be dealing with select statements. Because really, that's where the power of SQL lies. First, let's try to query from multiple tables. We say select star from, and this time we don't just mention one table, we mention 2. Now, when we run this, we get 32 rows back, a very huge table, and as it turns out, most of the values here are completely useless, completely rubbish data. What you find is that the first item from our first table is actually matched to every single item from the second table. This creates 8 rows because our second table has 8. Then we go down to our second item and that happens again. Basically what we get is 8 times 4 or 32 rows. Not what we want because this information doesn't make sense. This is what is known as a Cartesian product. You are basically multiplying the 2 tables together. And like I said, not very useful. How we can work around this is we can perform some filtering. We can say where prices.item is equal to sales.product. So what I'm saying here is that, well, I want to check from the sales table, the product column, that has to be the same as the prices table, in particular, the item column. So yeah, the idea is these two must be the same. If they're not the same, then the row contains irrelevant data. When I run this, now I only get 8 rows, and well, everything is actually relevant, right? Everything on the same line makes sense. Now, this particular notation can be a little bit unwieldy. It can be a little bit long, especially if you're using more than 2 tables. As such, we can actually alias our tables. For example, I can say prices as P, sales as S, and basically this gives me a short nickname I can use to refer to my tables. When I run this, well, the result is exactly the same. But the fact that it runs means that this syntax makes sense, right? So yeah, that's just a little bit of syntactic sugar to make things easier for you. Things are getting a bit cramped here, right? And as it turns out, we don't really need so much of information here. This particular column and this particular column hold the same kind of information, so I really only need one of them. And at the same time, the ID is also not very useful for me. Well, we've already learned how to get rid of certain columns, right? In this case, we only want p.item, p.price, as well as s.quantity. When we run this now, much better, right? Because we only see, well, relevant information. Now, this is where things start to get a little bit crazy because we can actually perform math inline as well. You see, I know my actual product, I know the price for one of them, and I also know how much a person has bought in a single transaction. But clearly, a more useful piece of information will be to see exactly how much they've paid, right? And as it turns out, it's a very simple calculation. Take a price and multiply it by the quantity, right? Because the price is a unit price. So when we run this, there you go. The multiplication actually happens. So in fact, right now, because of the way we've presented it, the number on the rightmost column is just a multiplication of the numbers from the previous 2 columns, right? So yeah, again, SQL can be very powerful. Of course, the column title here is a little bit unwieldy, but we've already learned of the as keyword. So in fact, we can tweak this up, right? We can alias this particular column as well, and now it looks much better. Now, the interesting thing is over here, this is an alias for a column, whereas over here, this alias is for a table. They're actually not the same thing, but we can use them, just very naturally, just very intuitively. So now we actually, well, don't really need these 2 columns, right? So let's take them away. And yeah, just have a slightly cleaner result here, which allows us to look at the next part. As you can see, what we have here are just several repeated items. If we want to see the grand total for each type of item, well, there is a way as well. Clearly, what we need to do is we need to group the similar types of items together. And in fact, there is a statement for this. We say group by, and we tell it which column. Now, if I were to run this, notice that our totals actually come back wrong, even though we have successfully, consolidated all of the same item together. That's because we've actually formed our query wrong. We've only told them we wanted to read back a total, but we didn't tell them which one. Again, SQL has a solution for this. You simply say sum. By doing this, you are summing up all relevant rows, and as you can see, now the numbers are bigger. Let's try and actually put the rest of our columns back so we can make sure that the math is correct here. First, let's bring back the price. There you go. So now we have the price inline as well for each one. Let's also bring back the quantity. Now, again, just having this on its own will give us a wrong result because this quantity is just one of them. But now we're dealing with a sum. So we need to do sum on the quantity as well. And yeah, again, right now, the math actually makes sense. These 2 numbers, when multiplied together, does indeed give us our total. Of course, we can easily, make this look a little bit nicer. For example, I can say as total sold, and this one will be as total earned. There you go, beautiful table, right? That is constructed from multiple tables, as well as a little bit of extra math on our part. So yeah, basically, this concludes our demo. Hopefully this shows you how powerful SQL is when used in a practical context. And despite that, there's actually a lot we haven't seen. In fact, just on databases itself, right, there is a lot of theory that goes into, well, how to create a good database design, how to ensure that, it always stays quick to query, and even just simple things like your primary key, your composite key. These have a theoretical significance, which is something that we didn't really delve into. On the side of SQL, there's quite a lot we haven't looked at as well. We've only seen sort of the simple way of joining two tables together, which is by using a selection, right, by generating a Cartesian product. But that is in fact not the only way to join two tables together. In fact, SQL has a join keyword that allows you to manipulate tables in pretty interesting ways. As hinted at earlier, there are also what is known as nested queries, where you have an inner query that generates a result, and that result actually feeds an outer query. So yeah, really this video is just the beginning. Just enough to get you familiar with general concepts. Hopefully this will be enough to tell you, well, what databases actually do and what they are good for. And there you have it. That has been SQL in a nutshell. And hopefully now you will know enough SQL to, well, basically implement a simple website. In fact, if you basically, set up your tables right, this is all you will ever need. For the most part, at least. Anyway, that's basically all there is for this particular episode. I hope you've gained some insight today. But yeah, until next time, you're watching 0612 TV with NERDfirst.net. Thank you very much for watching. If you like my work and are feeling generous, you can shoot me a one-time donation on PayPal or sign up for a recurring one on Patreon. Of course, you can simply like, comment, and subscribe. You know the deal. For more videos, links to my channel and a related playlist are on screen. Thank you for your support.